Aloha, Richard Halverson here. This is ICS211, and today I'm going to cover Quicksort. So let me share my screen. Okay, I'm going to do 18.6 and 18.7, and 18.7 is a lab. I'm not going to spend a lot of time talking about Quicksort because it's very difficult to explain. It's a lot easier to read. But let me just say that Quicksort, the way it works is it takes the set of data and it partitions it. It partitions it into a low half and a high half, and then it continually partitions recursively down until the array is sorted. It finds a pivot. It determines a pivot point, and it's usually in the center, and it takes that value. And partitioning involves taking all of the records on the right side and that are smaller than the pivot and moving them over to the left side, and taking all of the records on the left side that are bigger than the pivot and moving that over to the right side. So after it's done being after it's done being partitioned, then all of the records on the left are less than the partition, and all of the records on the right are greater than the partition. Okay, so then it has these two halves, and then it recursively partitions each half, and it keeps on doing that until it comes to partitions that are of size 1 or 0, and of course a partition of size 1 is already sorted because there's only one element, and then it's able to return and it recursively sorts the array by this continuing to partition. And so if you look at the quicksort algorithm, we see that here we load up an integer array. Here we display it out. Here we call the quicksort algorithm, and it's called on an array, and this is the low index and this is the high index. So when we start out, the low index is 0 and the high index points to the top element of the array, and it sorts it, and then after it's done sorting, it prints it out. How does quicksort work? Well, we see that the quicksort program, the quicksort method is right here, and what it does is it comes in, looks at I and K, looks at the low and the high, and if the low is greater than or equal to the high, then there's nothing to sort, and it just returns. Otherwise, if the lower is less than the high, in other words, there's some numbers there to sort, then it partitions those numbers. This is the low and the high. It partitions them into a low part and a high part, and the border between the low part and the high part is J. It's this index. In fact, this index here is the largest index of the low part. Everything higher than J is the high part. Everything J or below, index-wise, is the low part. And so what we do after we've partitioned this, then we go ahead and we call quicksort again on just the low part. This is from the beginning here up to the last index of the low part, and then we go from the last index of the low part plus 1, or in other words, the first index of the high part, all the way up to the top index here, and we sort that. How does partition work? Well, we have these two pointers. We've got a low pointer and a high pointer, and we find a midpoint, and then we take the pivot number as the value at that midpoint, and then it starts these two while loops here, where we start at the leftmost record, and while the numbers on the left of the pivot, while they are less than the pivot, while the numbers to the left of the pivot are less than the pivot, then keep on incrementing L until we find a number that is greater than the pivot. In other words, until we find a number on the left side that belongs on the right side. Okay, that's what this does. And so that's what this L is going to end up being. Also, we start at the top and we decrement H until we find a number on the right side that belongs on the left side. Okay, so by the time we're at this point here, then we have L pointing to a number on the left side that should be on the right side. And we have H pointing to a number on the right side that should be on the left side. And that's at that point, we exchange them, we swap them. And we keep going through this process until L meets H. And when L meets H, then all of the numbers on the left side, H and below, all of those numbers are smaller, are going to be less than all of the numbers above H. So that's how the partition works. Okay, so that's how Quicksort works. And this here, we go through some fun exercises. Okay, so here, what we're going to do is we're going to see how well we are at figuring out what which numbers should be on the left of the pivot and which numbers should be on the right of the pivot. So when we go through this, we're going to select all the values in the current window that are less than the pivot. And those are going to go over to the left side. That are less are going to go over to the left side. And then we press the partition button and we keep on going. And when we're done, this array that we started with should be sorted. So let's start this. And the pivot value is 2. So all of this, there's the only one that should be left of to the left of 2 is you got to pick at least one. So it's 2. And the next one, this partition is sorted. So go next. And then the pivot value is 89. So everything that's less than 89 is this is less than 89, this is less than 89, this is, and this is, geez, they're all less than 89. Okay, partition, and we end up with this here. Pivot value of 30. 30 is everything that's less than 30 is this one, and I'll just do that one. Partition is sorted. Okay, next. Now the pivot value is 30 again, so everything that's less than 30. I'm just gonna pick I'm gonna pick one of the 30s, I guess. What happens? Is that right? Yeah, next. Okay, pivot value 70. This is less than 70, and this is less than 70. Now pivot value 48. This is less than 48. Partition sorted. Next, partition sorted. Partition sorted. That partition is sorted, and we're done. Well, 87. I don't know if that made much sense to you, but you can try this out, and really helps you understand how Quicksort works. Okay, let's do the lab here. In this lab, we're going to read in some names, and we're supposed to sort it using Quicksort. We're going to we have to complete the Quicksort program below and the partition method below to sort the IDs in ascending order using the Quicksort algorithm. And so we're going to and output the IDs one per line. Okay, so this is an example. We read in these IDs, and the minus sign, -1 means we're done reading. That's the sentinel. And then we sort and we print this out. Okay. So we start out, we have to write the partitioning algorithm right here. We have to write the partitioning algorithm, which picks the middle element as the pivot, compares the values using index variables L and H, initialize to the left and the right sides of the current elements being sorted, and they determine if a swap is necessary. All right, so okay, so we have to plug that in, and then we have to plug in the quicksort algorithm, which calls partition and calls itself and partition, and then we have, this is the main program. We're going to use a scanner. It's an array list, string ID, user ID. This reads them all in. This calls quicksort, and this prints them all out. Okay. So it looks like all we got to do is fill in partition and fill in quicksort. Well, I'm going to go like this, and I'm going to pop open quicksort into a new window, open into a new window. Here we go. And let me put this over here, and let me put this here, and let me close this. And we're going to start with, I'm going to go down to here. All right, let's go to the beginning here. This is main, it's an array list. Instead of a integer, we read it in. Okay, what's quicksort? Quicksort is, let's static void quicksort array list user IDs, I and K, yeah. All right, I'm going to just copy this. Copy. And I'm going to put it here. Paste. So I've got integer j, and I've got this if when I is greater than or equal to k. So k is the top, I is the bottom. If I crosses k, then we're done, so return. Otherwise, it's not numbers anymore, it's user IDs. Copy, paste. I and k, and we're going to get back a j, which is an integer, and then we're going to quicksort user IDs, user ID there, and user IDs there. All right, that looks pretty good. Let's go up here and do this partition thing. Okay, so I'm gonna take all of, okay, it's an integer, it's an array list of user IDs, integer int I and k is very good. I'm going to copy all of this. Return h, high, that's the h is going to be the highest index of the lows. And right after h is going to be presumably L, is going to be the lowest index of the highs. All right, copy all this and paste it right here. Boom. Okay, so we've got LH int. Yeah, this is a midpoint, is an int. Pivot? No, that's going to be in array list. So it's going to be a string. It's going to be a string. This kind of string. And I think this is going to be a string also because that's what we use to do the exchange, to the swapping. And Boolean. Boolean is done. Okay, this computes the midpoint. This, not numbers. It's called user IDs. Copy, paste. That's the pivot. It's going to be, it's a string. Done is false. That's Oh, this has got to be user ID and pivot. That's right. Pivot's a string. And this has got to be, oh, yes. I can't do this. I have to use compare to, right? Yeah, so I gotta compare I gotta compare user IDs, L's, if user ID, if user IDs, okay, I can't, oh, I can't do this either, can I? I can't just, this is an array list. Can I, I think I have to, I don't think I can index, I don't think I can, I might be able to, but I really should be using get. And I should be using get here, get L. And I'm going to compare it with compare to pivot. It's going to be a capital T. Compare to this value. Okay, gotta close one more. So if it's less than 0, if it's less than 0, if it is greater than 0, if it is greater than 0, then no, this is H. So it compares, this is decrementing H while the thing that it's looking at is bigger than the pivot, while it's looking at string, values that are bigger than the pivot, then we're good. So go ahead and decrement H. It's when we find a value that's less than pivot where we have to stop, and that's going to be a candidate to exchange with this one. So here, while we are getting elements that are less than the pivot, we're good. So while this is less than this, that's what this less than 0 means, then go ahead and increment the L index, and this decrements the H index. Okay, that's good. If these cross, then we're done. So true, otherwise we're going to exchange these. And I think when I exchange, I got to do temp is going to get the L1. Copy. Temp is that. And then we want to this is going to be it's going to be user IDs. Set at index L, set at index L what user ID is at H. Yes. Okay, that sets this gets what's at L and puts it in there. This takes what's in H and puts it in L, and then we got to take what's in then we have to set set, we have to do user ID set H. We're going to set that equal to temp. And then we're going to decrement L and decrement N. We're going to increment L one more time and decrement H one more time. And that's when, and then we return H. H is what gets returned. And it gets returned, you know, down here someplace. Oh, it gets returned here. All right. So I don't know, this might work. Let's see. Let's take a look. I'm gonna put these people in here. Copy. Paste. Okay, so those are that's the input. And what happens when I run it? Okay, so wonder what I forgot. Let's see, Java 94. Okay, I'm just some initialization. It's an initialization thing. Midpoint IJK. Quicksort J. Okay. Let's see. String user ID, that's calls that. That calls that. Let's see if this is it. Okay, well, that looks pretty good. I think I will, I think I'll leave it there, and hope this helps. Thanks for watching.